Welcome back, chemistry fans. Today we are going to deal with a calorie counting lab and not what you eat. No, but it's going to be what we burn. So we've got to figure out how to do this as a laboratory. Let me share with you my other camera and we will get started here right away. Okay, so what you see now in the camera is the setup for the laboratory. And we have right here some remnants of the Rice Krispie treats, which is just mostly sugar. And then we have a couple of samples of a cheesy poof, and that's going to be mostly fat that you see. Back here, we have an apparatus for which we're going to skewer the food on so it rises up above so it could actually burn. We got to get the weight of the food. And then we have this device here. Now, this device is how we are going to try and capture as much heat as possible. It's all aluminum, so that holds in the heat pretty well. It's not insulated. Inside of it, though, what you see is that that lid actually comes off, and in here, this is what we're going to put some liquid in. So we're not actually going to directly measure the heat. We're going to measure how much heat is transferred to the water. So it's an imperfect process, but we'll do the best we can. So we will take this as our object that we're going to heat, and then we would skewer it on here as such. And then we will, after we've burnt it, or after we've got it ignited, we're then going to cover it. And hopefully the heat will not escape through this hole, but that's how we would light it. And then the heat will transfer up into the bottle. We will take the temperature with a thermometer, with a temperature probe that will be into the water like this. Okay, so let's get everything set up so that we can do this activity together now. Okay, first thing that we are going to need to do is to measure out 25 milliliters of water, maybe 50 milliliters of water. Let's see how much it makes, how much it fills up this glass container here. There's a line of 50. So we'll go, we'll put it up to we'll do the 25 so that we have a big transfer of heat. So hold on just a second. Let's fill that up, get that going. All right, so here I am coming over here. I'm gonna measure out 25 mils. And it's got to be room temperature, nothing special about it. Doesn't really matter what the temperature is, as long as we record it, we'll be fine on what it is, how much it is. All right, I just got to add a drop in. And there's your 25. Okay, so now I got 25 milliliters. I'm going to go ahead and pour it into my Erlenmeyer flask, which is attached to this lid here. So I've got now 25 milliliters of water in here. So I can put that into the burning apparatus. I'm going to go ahead and I'm going to take my thermometer and I'm going to put it in here. And so that you can see what we're up against here. You can see what my current temperature is with the glare there. You can't, but 24 degrees is roughly where we're starting here. And so we'll need to record that piece of information. I'll keep this off to the side. Here I'll get a holder for that one, so hang tight. Let me go get that. Okay, so now you can see in here what our temperature is and the apparatus we've got. I have already got this guy skewered, but we need to get the weight of it. So I'm going to go ahead and turn on my scale here. And let's see if it actually will start a reading. Okay, so now, here we go. And we're going to get the mass. So we need to delete the weight of the apparatus that we're using to hold the weight. So let's tear that out of there. Let's tear that out. Okay, now we can put on our poof, cheesy poof. 0.65. So we got to write that down. Okay, so we got that weight there. Now what we can do is we can actually start the process of the burning. We got to make sure we have our temperature readings on here. Good. Okay, so what we're going to do is we're going to take our little matchstick here and we're going to ignite it up. and we're going to set this on fire, but we need to do it from the bottom of it so that heat always builds up. And then as soon as we've got the flame lit, then we can cover it and try and capture as much of that heat as possible. So we'll hopefully see the change in the temperature. Now, how do we know when to stop? Well, whenever that heat temperature has started to decrease, that's whenever we know we are done. Now, this is still burning underneath there. You can hopefully see it now. Yep. And it is getting warm. When I picked this up, I didn't realize that it didn't fit very well, so I would have used a different container had I known, or a different holder because it's too high. But this one, we're still capturing everything. All the heat is still going to it. It looks nice and nasty. You can see some of the heat going to it. Now, the flame is out, but we're more concerned with over here, this temperature. So does it continue to increase? Yes, it does. Oh, it looks like it went up to 49.4. It looks like that's the hottest it got. 49.5, 6, 7. $50. Is it going to go up? A little bit. Looks like 50.1 may be the top temperature for us. Okay. So we have our maximum, we have our minimum. All right, so now we are going to repeat the same process. We need to get fresh water because we don't want to exceed the 100 degrees that water has the capacity to hold. So, nasty. This material, the leftover remnants, we need to now weigh, because we know what the original amount was, but now we need to add up what the final weight is. 37.79. All right, so we will get that off. 37.7. Hello. As well. How are you today? Okay. So we've got our first one. We are back now. 23.7 degrees is what we're going to start off with. And that's going to be for our second. So this time what we're going to burn is the second material, which is just a little, mostly it's sugar. It's going to be the remnants of your marshmallow treat. So I've got it skewered on here. And so let me get rid of some of the excess there. Oh, untear it. Go back to 0. So now we can get an initial weight, 38.83. Okay. Now we can start with the, oh, you didn't get to see it there. There it is, 38.83. All right, so now what we're going to do is the exact same process. We are going to burn this food, and I'll have to hold it again to make sure that that it doesn't touch the bottom of the water container. This one will go up a little bit faster. It's got a little bit more energy content to it. Fast burning, just the same way that you have fast burning food in you eat carbohydrates, and they don't tend to last very long in the body. All right, so there is that scenario. You can see the food is burning. It's in the heat tent. I don't feel any heat yet coming off of it, but what you'll notice is it doesn't burn very fast. Oh, and that's it. That's the end of the heat. So let's see how much it came up with. 24.4 looks like that may be the end. 24.5, 6, 7. Not going to go up much more. 8, 9, 25. It made it to 25. Woo-hoo. 2, 3. Uh-oh, went to sleep. 25.5, still going up just a little bit. 6, is it going to hit 7? It might. That looks like that's going to be where it plateaus. 25.6 degrees Celsius. Okay, now let's get the final mass. Oh, no, it did go to 27 just as soon as we talked. Isn't that crazy? All right, so now let's go ahead. We don't need this anymore, so we can get rid of that. Let's get the weight on this. So we've got our final mass, and we can watch this one come on. See how much mass we lost. 38.78. All right. So now I've got all of our data collected for the burning of the food. Now we go into the calculations. So hang tight and let's do that right now. Okay, so now we are on to the calculation portion of this lab. So what we got to do is we've got to calculate what is the temperature change for both of these. So for the cheesy poofs to the left column here, I ended at 50.1. I ended at 50.1 and I started out at 24.4. That means I've got 25.7 degrees of change. So that's my delta T. And over here, 25.7 minus 23.7 means I only had 2 degrees of change. All right, so already you can see it didn't heat it up a whole lot. Both of them used 25 milliliters of water. Let's go ahead and calculate this. This will be later used, but for right now, oh, and by the way, that equals the same thing as 25 grams. Let's go ahead and do this. That will be the second portion of our calculation. So the difference between these is how much was lost in the material as it burned. So before weight, after weight, 37 minus 0.79, and we get 0.67 grams burned, 38.83 minus 38.78, not much, 0.05 grams, not much was burnt up, not much was lost in the process. Okay. Now what we're going to do, we're going to go over and calculate our delta H. So this is the heat, and then we'll convert those into calories. So heat is equal to mass times specific heat times the change of temperature. Well, for all of this, yes, we're calculating the heat of the food, but we're actually figuring out how much of that heat was transferred to the water. So we're going to assume, which is not true, but we're going to assume that all of the heat burned from the food transferred to the water. So we're going to use 25 grams of water. The specific heat of water is 4.18 joules. Now, if we want to be in calories, which is what we want, we would actually only have to use 1. Now, the change of temperature is 25.7 for the cheesy poofs. So I got 25 times 25.7, and it says that it's 642.5. And you're like, that's a lot of calories, but these are actually not kilocalories. These are just calories. So we divide that by 1,000, and you end up with a very small amount. 0.64 calories is what the cheesy poofs end up having. Not a whole lot. But now we compare that per gram. So how much of the gram was burned up? 0.67. So divide that by 0.67. So 0.64 divided by 0.67, and you get 95. Well, 0.95 calories. That's almost 1 calorie. Let's do the same calculations now for the cheesy poof. So what we're going to do is mass is 25. The specific heat is 1. The temperature change ended up being 2. So that is a total of 50. Divide that by 1,000, and you end up having 0.05 calories. But now let's take it divided by 0.05, and you actually end up with 1 calorie. Look at that. So they both end up having about the same number of calories. Now, what should have happened per gram is we should have had these values here. So they're not quite right, and that's probably where the heat was lost, but that's okay. So you would just do a percent error calculation based on those values compared to the correct values. The correct value should have been 4 for the marshmallow. It should have been 9 for the cheesy poof. Okay. So with that said, we've got the best we can do. It's not great, but this is how we would go about calculating our heat for it. Okay, thank you very much for your time. And I will again, hopefully talk with you soon. Bye-bye.